guys, sorry I'm not there today, but I don't want to get behind, so we're going to do some video notes. Alright, so today we're going to solve, or first we're going to simplify rational expressions, and then we're going to solve rational equations. So a real quick review of how we multiply fractions. When we multiply fractions, we do the top times the top and the bottom times the bottom. But to avoid big numbers, we can simplify ahead of time using canceling. So if there's a number on the bottom and a number on the top that can be divided by the same thing, we can simplify that way. So in this example, the 12 and the 18 can both be divided by 6. And if I do that, 12 divided by 6 is 2, 18 divided by 6 is 3. And then I can do the same with the 21 and the 49. Divide them both by 7, and we get 3 and 7. And now when I do top times top, bottom times bottom, I get 14 over 9, and it's already simplified because I did it ahead of time. And then when we divide fractions, it's almost the same as multiplying with one additional step. We always multiply by the reciprocal of the second fraction. So I keep the first fraction, and I flip the second one and change it to multiplication. And then I can do that same canceling trick now that it's multiplication. 15 and 5 can both be divided by 5, giving me 3 and 1. 32 and 24 are both divisible by 8, giving me 4 and 3. And then top times top, bottom times bottom gives me 9 over 4. Okay, so we're going to use those same properties to multiply rational expressions. So in part A, the first thing we want to do is fully factor the expression. So I'm going to factor the top. I do my two binomials. X squared minus 2x minus 1 factors to be, well, we need x's in our first spots to multiply to x squared. We need 1's in our last spot to multiply to 1. And then we need our inners and outers to add to negative 2. So if I put 2 minuses, that should work. On the bottom, x to the third plus x has a greatest common factor of x. So I factor out an x, and I get x squared plus 1. Top of the next fraction, I can factor out a 4, and I get 4 times the quantity x squared plus 1. And on the bottom, we get two binomials, x, and then we're going to need 2 and a 1, and for these to add to positive x, we want a positive 2 and a negative 1. And then I check to see what cancels. So anything on the top can cancel with anything on the bottom if they're the same, and it doesn't matter if they're in the same fraction or different ones. So, for example, the x minus 1 on the top of that fraction can cancel with the x minus 1 on the bottom of the other one. And these x squared plus 1's cancel as well. And then we write what we have left, which would be 4 times x minus 1. I just moved the 4 to the front when I multiplied the tops. And on the bottom, we get x times x plus 2. And you can just leave it in factored form like that. Now when we divide fractions, it's the same idea, except we're going to multiply by the reciprocal. So I'm still going to put it in fully factored form, and I'm going to change it to multiplication and flip the bottom fraction. So I'll do that part first. X plus 3 over x squared minus 4. And I change it to times, and I flip that bottom fraction. So 2x to the second minus x minus 6 goes on the top, and x squared minus x minus 12 goes on the bottom. Now I factor, and we get x squared minus 4 is the difference of squares, so it's x minus 2, x plus 2. And on the top of this fraction, I'm going to need a 2x and an x to multiply to 2x squared. And then I need some factors of 6. I'm going to guess 3 and 2. If I put a 3 here and a 2 here, my outers give me 4x and my inners give me 3x. And if one of those is negative, I should be able to have those add up to -1. And I'm going to want my 4x to be negative, so I put the minus in front of the 2 and a plus in front of the 3. And then on the bottom, I factor x, 2 factors of 12 that add up to -1 are going to be 4 and 3, and we're going to need -4 plus 3. And now I check to see what I can cancel, and my x plus 3's cancel, my x minus 2's cancel, and it looks like that's it. So I write the result, which is, what was left? 2x plus 3 was left on the top, and on the bottom we have x plus 2 times x minus 4. And that's it. Now we're going to solve rational equations. So we're going to move to the next page. And to solve rational equations, it's going to be a really similar method to what we did when we were solving linear equations that have fractions. I want to multiply both sides of the equation by the least common multiple of the denominators so I can cancel out those fractions. So I need to come up with the least common multiple of 2x, 3, and 6x. And remember, multiples are multiples of 2x, or multiples get bigger and bigger, so don't confuse it with factors, but the least common multiple of 2x, 3, and 6x is going to be 6x. 6x is divisible by all of those things. So I'm going to multiply both sides of this equation by 6x. And when I do that, I should be able to cancel out those denominators. Now I have to distribute to all the terms. So first I'm going to do 6x times 5 over 2x. And remember, this is like 6x over 1. And I can divide 6x by 2x first and then multiply by 5. So 6x divided by 2x is 3, which I then multiply by 5. Then we're going to multiply 6x by the 2/3, and I'm going to divide by 3 first. So 6x divided by 3 would be 2x, and we get minus 2x times 2. And on the other side, the 6x cancels the 6x, and we just get -1. And now I have an equation that doesn't have any fractions. So we get 15 minus 4x equals -1. Subtract 15 from both sides, and we get -4x equals -16, and divide both sides by -4, and we get x equals 4. Now, you always need to check rational equations for extraneous solutions. If we look back to the very beginning at the denominators, any number that makes any denominator 0 would not be allowed as an answer because it would make the function undefined. And the only value of x that could make the denominator 0 is 0. So x cannot be 0 in this case. And since we didn't get 0 for our answer is fine, assuming it works. And we can plug it in and check, but I'm not going to. This video will be a mile long if I do that. Okay, next one more example, two more. And the next one, our least common denominator, or least common multiple of the denominators. We've got 2 factors in the bottom. There's an x minus 7 and a 2. So both of those are going to need to be included in the least common multiple. So I'm going to multiply both sides by both x minus 7 and 2. And again, we have to distribute that to all the fractions. So in the first one, on the left, when I multiply, the x minus 7s are going to cancel, but the 2 won't, and I'll get 2 times the quantity 2x minus 9. When I multiply times the x over 2, the 2 will cancel, and the x minus 7 won't. So I get plus x minus 7 times x. And then when I multiply on the right side, the x minus 7s cancel, but not the 2, so we get 5 times 2. And then we go from there. So I distribute, and we get 4x minus 18 plus, distribute this x squared minus 7x equals 10. And combine like terms. And we get x squared minus 3x minus 18 equals 10. I'm going to subtract the 10 from both sides. I seem to have a quadratic equation, so this is a toughie. And we get minus 8 equals 0. And this one we would have to solve by factoring if we can. But it doesn't appear to be factorable because our factors of 8 are 2 times 4 and 8 times 1. So we would have to use the quadratic formula. But I really don't feel like it. So we're just going to stop here, and I'm going to promise you that I won't do that to you on the quiz. And in the interest of time, we're going to go on to one more example. And in this one, the least common multiple is a little bit harder to find because it's not in factored form. So let's rewrite this totally factored, or at least that x squared plus 4x, we should factor that. I'm just going to do it right below, and well, I'll rewrite it. 3 over x plus 4 equals 1 over x plus, I'm going to leave the 6x plus 12. But I need to factor x squared plus 4x, and I get x times x plus 4. And I see that it has 2 factors that show up in the other fractions, so the least common multiple of the denominators is going to include x and x plus 4. And so I'm going to multiply both sides of the equation by both of those factors, x and x plus 4. And we distribute. So on the left side, the x plus 4's cancel out, and we're left with x times 3. On the right side, when I multiply by 1 over x, the x's cancel, and I get 1 times x plus 4, which is just x plus 4. And then for the next part, the whole x and x plus 4 cancel, and we just get 6x plus 12. And then we go from there. So we get 3x equals, I'm going to combine like terms, 7x plus 16. And subtract 7x, we get negative 4x equals 16. And x equals negative 4. And again, we want to check for extraneous solutions. And if we go back to our original equation, and we look at what numbers would make the bottom 0, x equal to negative 4 and x equal to 0 make the bottom 0. And we got x equals negative 4 as our answer. So that means that it is a bogus answer. It's an extraneous solution. It doesn't work. So the one answer that we found is extraneous, and that means this equation has no solution. So you always want to check for extraneous solutions in rational functions.